Static simulation homework solution. Uh, Question 3 is about simulating a part which is called Mania, and we need to find the stress and displacement plots as a result of the applied loads. So you see that the fixed geometry, it says that is inside face of the two holes that we have here. Total force of 2000 Newton are applied to here, so the summation of all of these forces should be 2000 Newton. And it should be exerted on the holes inside of this face. So it's applied to these inside the wall of these holes, each of these holes. The material is given as brass, but it's giving me the mesh element size, the minimum of 1 millimeter, maximum of 2 millimeter. So we're going to use this information to perform our simulation. So we have the part here, so we can start our simulation. Make sure that a static select that. Then go to enter as a name. It's called Mania. First, we need to apply material. So right click on this part, apply material. Problem says it's brass. So go to the this copper alloy. It's brass. Apply. Okay. So material is applied to that. Next, we have to define fixture. Right click, go to fixed geometry, and it says the fixed geometry is this, the two hole faces. So here would be my fixed geometry, and then you can go straight up to the loads. The loads is going to apply to these all four holes that we have here. External load, force. Now I select all of these holes that we have inside first. First, we have to figure out about the direction because it's normal and it's not what we want. The problem says it should be like perpendicular to plane. So select direction. Maybe the best bet would be perpendicular to right plane in that direction. So select right plane as your reference and have to change that this it would be in that direction. Essentially force can be applied here. This is total, not per item. If you select for per items, every value here would be for each of the forces, but the total should be 2000 Newton. Change it to English, and in the perpendicular direction, which that is would be 2000. Actually it says Newton, not, so I have should not change it to English. It should be SI. So change it 2000 Newton. So 2000 Newton applied, and in the direction is matching the direction that we wanted, and hit OK. So we have the resultant force of 2000 Newton and the fixed geometry that is here. Let's go create mesh. Click create mesh, but the mesh size is custom with the minimum and maximum. So select mesh parameters, and in parameters we have to select what is the minimum. So maximum element size 2 millimeter, and minimum element size is 1 millimeter. Hit OK. That is gonna mesh the entire parts based on that spec, and we have to be ready to simulate the parts. So this is our meshing system. Now run this study. Okay, so you see that as we expected, this is getting stretched as a result of that force in that direction of the force plot. Okay, stress plots, they wanted PSI, and with finding the maximum and the minimum stress points. So change it to PSI, go to chart option, change it to floating, maximum and minimum. Okay, you will see that the minimum force is in the fixed joint with 45 psi, and maximum happens somewhere here with 26,000 psi. Still, we are less under yield stress, meaning that factor of safety expected to be more than 1. Displacement, they want a minimum maximum, and in millimeter. So it is already a millimeter. Maybe I only change the display of the numbers as well as minimum maximum. So minimum should be the fixed one that we have, and the maximum is 0.159 millimeter at the end of that clamp pump. Factor of safety, right click and create a factor of safety plot. As we expected, it should be more than 1, and the actual number is 1.3. So the plot should be safe as a result of this. I hope you enjoyed watching out this solution. Thank you.